Garnett. Today I will be presenting COVID vaccinations in the United States, predicting future COVID vaccinations, and assessing demographics of the vaccinated. This is for my CS 588 Section 1, Big Data Computing, which is due, and the final project is due November 29th, 2021. There are two main parts of this project, each with their own purpose. For the first part, I'm trying to predict future vaccination levels. This can be beneficial because it can help political and corporate leaders set expectations for the public, as well as help make beneficial policies that keep people safe. Second, the second part of this project is to study demographic breakdowns of the vaccinated. The demographics that we will be looking at is age group, race and ethnicity, and gender. And we're doing this because understanding the vaccinated may help us understand the vaccine hesitant. It may help convince those that are hesitant to get vaccinated. So data identification, this part of the life cycle, big data life cycle, I found this data set right there, which can be found right here. It took a little bit to find this data set, partially because I was still trying to figure out what I wanted to do specifically. However, once I found this data set, I realized what I could do with it, and that's why I chose it. For the data acquisition and filtering section, for the first part of the project and the second part of the project have different steps here. So for the first part of the project, we had to filter for specific rows, specifically the rows that had demographics equaling the US, and that means we have to ignore all the other rows here. And if we flip through, we see that the US is there every so often. So for example, we would take this, but we would ignore every other row here. So that would be some of the filtering that we would do for the part one here. For the second part of the project, we focused on one attribute in particular. So we either focused on the total number of vaccinated within a group. So for example, there are 120 million females that are vaccinated on November 29th, 2021. Similarly, there are 71.7% of females are vaccinated as of November 29th, 2021. So we did two separate things because I thought it was important to look at the both total number of vaccinated and then the percentage of that group that is vaccinated. And for both of these, we're looking at specifically the first dose because I felt like that is an important step because once you start the vaccination process, most people finish it. So I decided to focus on the first dose because of that. So for data extraction, I had to modify the data a little bit. So for both parts of the project, it required using a date. And unfortunately, using the date as was not convenient. It wasn't easy to do. It was in a month, day, year format. And so I converted it to an ordinal where 0 is December 13th, 2020, and which so happened to make 343 equal to November 21st, 2021. I'm hesitant to say it was actually impossible, but it wasn't convenient, and so I just used the ordinal dates because that made the math easy. I did not need to validate or cleanse any of the data. The CDC is a reputable source, and they have resources based on their that can explain how they collected this data. Data aggregation was not needed. All the data was consolidated. Data analysis. So we performed regressions, predicted values, and did performance evaluation via root mean square error and the R2 score. So I'm going to run the parts of the project. So first I have to do a conda activate statement just because that's how that's run on mine, Python 3. So vaccine.py runs the regressions, so linear, logistic, and the polynomial regressions on the entire data set. So we'll see that in a second. So as we see here, we have a linear regression. Here's the logistic regression. polynomial with a fourth degree, and each one you can see it gets more accurate. Finally, we get to seventh degree. This is the last one. After I close out of that one, it prints out some data for me. So first it says the actual predictions for each of those for the next 7 days. So today is the 29th, but the data set I'm working on is from the 21st. So this is expectations. This is the data. This is predictions from the 21st into the future. So it would go up to the 28th. And we also have some performance evaluations here with root mean square error and the R2 score for each one. And as you can see, the seventh degree polynomial is the most accurate here with 0.9998, as opposed to the other ones, which are less than that. Going back to this, we're also going to run, excuse me, I meant to also run this. So vaccine.py runs it so it trains on the entire data set and then predicts into the future, which would be useful in a realistic situation. However, I wanted to test this, so I was using prediction.py, which breaks it up into a training set and a testing set. And so the training set I kept, the testing set I kept rather small because I'm aware that polynomial regressions would probably not be very accurate if you're predicting far into the future, because polynomials will change fast as x grows, and x is already pretty big. So this one's the linear regression, and we have the black here that represents the actual points, and then the orange here as the predicted points, and the same thing for here for the pink and blue. Logistic, polynomial fourth degree, polynomial fifth degree, and then polynomial seventh degree. So that was that. Again, we have performance evaluations here. This top one here is on the training set, as you can see. And again, here, this is on the testing set. Again, we see that polynomial regression with seventh degree is the most accurate, and we kind of see the same order from linear to logistic, fourth degree, fifth degree, and then seventh degree polynomial as the order of least to most accurate based on these scores. And then up here, I have the predictions for each one for the previous week. So again, this data set is from November 21st. So this would be everything from the 15th until the 21st. So this would be as if you took the predictions, you took the data set from the 15th, and then you ran prediction.py on that. Vaccine.py would do similar things as that and do similar, make similar predictions. It just wouldn't be able to do the testing set performance evaluation because we wouldn't have the actual data there. All right, so data analysis, we completed that for part one. So for part two, there wasn't much data analysis for the second part of this project because that was mostly creating visuals. So the plots that we already went over were the major part of visualization for the first part of this project. We're now going to look at the interactive plots for the demographic analysis. So this can be done by doing total demographics. So right here we have a bar chart that represents the distribution of vaccinations based on age group. So as you can see, these are these are mutually exclusive. And as we go through these, you can see trends. Something I like to note is that you can kind of see that you have 25, 40, and 50 go up first. And I think this is just me postulating, but I think that's those in the medical field. And then we start to see those that are 75 and up and 65 and up getting vaccinated. And I think that's when that age group was able to do it. Same for 50 and 64. And I think beyond this point, it's open to everyone. I'm not 100% sure, but and that is present data as of November 21st, 2021. We'll get to do the same thing with gender. And again, I like to note that there's such a inequality right here, and I'm not sure, but I would like to think that's because there are more women in the medical field. If you consider nurses and doctors and surgeons, I'm not 100% sure, but I think that's it because it's still fairly early on. And you can see that women are more vaccinated throughout the pandemic than men by quite a bit too. That's 20 million, I believe. One, two, three, 4, 5, 6, 7, 8. Yeah, 20 million. And then finally, we have this one for race and ethnicity. Um, so I'm just going to do this. So race and ethnicity, I believe Texas doesn't record this, so that's why that number is so big for unknown, um, which is a major thing, and that's why I included it in this one, but I didn't include it in age. There's technically some people who didn't have their age known, but it was so minuscule, it was less than 0.5% of the population. So So that was all for total demographics, um, which is great, but it doesn't really give you the full picture. And that's why I also threw in percent demographics. So it starts at 0 because obviously no one is vaccinated at this point. And so as time goes on, we get to see that different groups get different groups get vaccinated. Um, we start to see a general trend of as you get older, you're more likely to have been vaccinated, which is interesting because when you look at the other one, age 75 and up is lower down, and I forgot uh, that they just have a smaller population overall. So it's important to see the percentages too, the percentage of the population, to get a full picture. So this is one of the things that I left, but is technically an accident. So we have unknown here. However, you can't know the percent of a population if you don't know what that population is. So this would not have any values throughout the whole thing. I left it there so I can make sure I can discuss it in this video. And again, we get to see the population, the percentage of a population that is vaccinated for male and female. It's about 5% throughout, I would say, is the difference. So that's interesting to see. And then finally here we get the age group, the race and ethnicity. And we see that people who identify as non-Hispanic, multiple, or other are the most vaccinated. And everyone else is kind of meandering between 40 and 50, with the exception of non-Hispanic, what is that? Alaskan Indigenous and American Natives. So that finishes those. And from this project, I have learned many new things. First, men are less vaccinated than women and have been throughout the entirety of the pandemic. I kind of had a sense of this because men are generally stereotypically less concerned about their health or less intelligent about health decisions. So I could have gathered that, but I didn't know for a fact. Uh, the second thing I learned is vaccination levels trend upwards with the given age groups. Um, I actually did not know this, and I thought opposite of this because you hear about a bunch of people that are anti-vax, and for the most part, they're older people, at least in my experience. So this was interesting to see, and I'm actually happy about it because older people are more vulnerable. So I'm happy to hear that they're generally have higher vaccination rates. And then lastly, currently non-Hispanic whites make up the majority of the vaccinated, yet they have the lowest vaccination, the second lowest, excuse me, that is a typo, but they have the second lowest vaccination rates in that demographic, uh, in the demographic category that measures for race and ethnicity. So, yep, that wraps up my project. Thank you, and it's been a great class. Thank you.